Hey everyone, it's Coding with Kareem or Tech by Kezi, and today we're going to explore what makes interfaces so powerful and why I think interfaces best help us understand polymorphism and abstraction. So we'll go through a pretty simple example today. I'll try not to make it too complex, and we'll essentially generate different objects with different types. They'll have different implementation details, but we'll see how we can still have some sort of unified access through one or two common interfaces. And we can also see how interfaces allow us to abstract code and hide away, complexities that we probably don't care about. So let's begin. We're going to start off looking at all of the interfaces, and then we're going to look at all of the classes that implement and inherit from the interface, and then we're going to finally see where the objects are initialized. So the first interface that we're going to look at is the iCharacter interface. It has three members. So any object that inherits or implements from iCharacter needs to have a name property, a health property, and needs to have a take damage function that returns void or returns nothing, that also takes in a damage argument. So the next interface we're going to look at is the iWarrior interface. This is pretty simple. It essentially inherits from iCharacter, so it has all of the members or fields iCharacter has, but it also forces any object that inherits from it to include this attack function, which returns void, so it doesn't return anything, but needs to take in a valid character, which is any object that implements this iCharacter. So this isn't, you guys can already see how we're adding the seeds of abstraction here, since iCharacter could technically be a bunch of different classes. But moving on, we have the iProtagonist interface, which again, this actually inherits from the iWarrior interface, but it also gives us access to this plot armor. Not doesn't give us access to, it forces us to implement it. And the reason why we have this plot armor properties because every protagonist or main character has plot armor. So moving on, finally, we have the iEnemy interface. Similar to the iProtagonist interface, it inherits from the iWarrior interface, and it also makes us implement this threat level property, which essentially, defines whether an enemy is a normal enemy or a boss level. And we'll see how that'll actually implement or influence the way they attack and things like that. So now that we saw all the interfaces, let's actually look at the classes very quickly. We have the character class that, implements the iCharacter interface. So we have name, health, and then we have take damage, which is virtual. This virtual keyword is important because using this virtual keyword actually gives us a little bit of the seeds of polymorphism, since we can actually any class or any object that inherits from character can actually choose to override this function and kind of scratch whatever we're doing in line 20 and define your own instructions. The only thing that you do have to stay consistent with is the function signature, meaning that the function needs to remain void, and it also needs to continue taking a damage parameter. So knowing that, let's move on to the next class. Well, let's look at the warrior class. This warrior class simply inherits from the character class, but also inherits or implements the iWarrior interface. So because of that, it has this attack. Actually, I think the iWarrior interface only forces the attack method. Am I correct? Yes, it does. So because we have this iWarrior interface, we need to implement this attack method, which we do here. But similar to what we saw before with take damage, this attack method is virtual, meaning that any object that inherits from warrior can choose to define its own implementation details for attack. So again, we're seeing a little bit of the seeds for polymorphism. The next class we're going to look at after warrior is main character. So main character inherits from warrior, similar to how warrior inherits the character, but because main character inherits from warrior, it inherits from warrior and character at the same time. It also inherits or implements the iProtagonist interface, which forces it to have this property here, plot armor. And as we guys saw here, you guys saw how we declared virtual functions for take damage and attack. I believe take damage is a virtual function in the character class, and attack is a virtual function in the warrior class. But because they're virtual, now we can actually override them. So as you guys can see, for take damage in the main character class, we do call the base method from the character class. Let's actually take a look at it here from the character class. We actually do call it, but we do some extra logic that ensures that if we do hit 0 health, we get a boost. And we do something very similar with this attack method. We override it and we attack a character once. However, we also do another round of attacking, and it depends on their plot armor, of course. So if we have a lot of plot armor, we pack a much fatter punch. So the last class we're going to look at is there are a couple of classes. They're the Gremlin class, the Goblin class, and the Minion class. They're all in this enemies file, and they all have a very similar structure. They inherit from the Warrior class, and they also implement the I enemy interface. And as you guys remember, this I enemy interface requires this object to implement this threat level, and we have it as a property in this class. And depending on what the threat level is, I believe it can either be 1 or 2. This is an enum level, yeah, so it can either be 1 or 2. If a gremlin, a goblin, or a minion is a boss, he then gets his health multiplied either by 2 and his attack damage by 2. If he's not, it just stays the same because the values are either 1 or 2. So that's essentially how we set up Gremlin, Goblin, and Minion. And again, as you guys can see, we override the attack method. This attack method that we're getting is because we're inheriting from Warrior. So we have to implement it. Well, technically it's already implemented, but we decide to override it, and each one of these little enemies has their own console log line. So as you guys can see, we're defining different implementation details, which is important for the idea of polymorphism. It's also important for abstraction because we don't necessarily want to see this code later down the line when it comes to actually calling these functions. All right, so now that we saw all of the classes and the interfaces, let's look at how we can use all of the code that we defined to actually define clean code and use objects in a way that better help us understand what polymorphism really even is. So now we're in the program file. This is the entry point to our program. In this main function, we declare a main character with the main character class. So we generate some, new distinct ID. Today, our main character is going to be Sonic the Hedgehog, and he has very high plot armor. And on line 19, as you guys can see, we generate an enemy army. But we do something very interesting in this enemy army. We generate a list of I warriors, meaning that we generate a list of objects that all simply need to implement I warrior, meaning that they can be of different classes. So immediately you guys should be thinking, wow, this is an example of polymorphism. And it's right. We have unified access in this list, which ends up becoming an enemy army through the iWarrior interface. And in this list, you guys can see we're passing in gremlin, minions, goblins, even more gremlins. We're technically passing anything that can implement iWarrior. And as you guys can see, gremlin, minion, and goblin, you guys saw beforehand, definitely can't because it implements or it directly inherits the warrior class, and it also implements the enemy interface, which if you guys remember also inherits iWarrior. So we know that gremlins, goblins, and minions can all be valid warriors. So this is an example of polymorphism. Now we have an enemy army of not just, gremlin, minions, and goblins that all have their different attack methods, all have their different logs. No, we have a standard warrior army. And we can really, really see where this actually becomes really important in this battle method, right? So in this battle method, we pass in the main character and the enemy army. But if you actually look at the parameters at the battle for this function signature, you guys can see the main character, the type is actually just any object that implements the iWarrior interface. And we know that our main character does, right? We set it up so that our main character is a warrior. If you guys go back to the main character class, it inherits from warrior, and meaning it needs to implement the attack method, and it does. And not only does it implement it, it also overrides it and adds its own logic, which is a form of polymorphism. And it's also abstraction because we don't necessarily have to check the type of each one of these objects before deciding to add all these custom logs. As you guys can see, main character has its own log for attack, just like Goblin has its own log for attack, just like Minion has its own log for attack. This isn't an example of abstraction because we don't have to write if enemy is, yada yada type. It doesn't matter. We can simply call attack and both of these objects, enemy and main character, are of a unified type warrior. They both call the same attack method, but internally they actually have completely different code details. And we can check this, right? If we actually just attach the debugger very quickly, I don't want to spend too much doing this because I think this video has already taken a good amount of time. Did I forget how to debug in Visual Studio? No, I did not. Okay, the first enemy that we get is a, oh no, guys, what's going on here? I'm going to ignore that. All right, let's step into this function. We're in the gremlin class. All right, so our first enemy is a gremlin, and we saw that attack method, and now we're in the main character, and we get our own custom attack method, as you guys can see. All right, our second enemy is now a minion, and as you guys can see, we get a custom log, and our main character attacks, which calls take damage, which calls the virtual original take damage method. But let's just see it one more time. When the enemy calls attack, when we inevitably call take damage, character take damage, we call our version, the main character's version of take damage, which is a version of polymorphism. While we also have all this extra code that we don't manually have to manage in the program file. So I'm going to end this. As you guys can see, um, in this battle function, each one of these attack methods has its own internal different logic depending on the enemy. But this works because they all respect the iWarrior interface. So to me, this is what makes interfaces so powerful. We can define interfaces and make our code much more polymorphic, make our classes work together in a way that's a lot more functional, while also deciding when to expose uh, specific implementation details. For example, we saw examples of abstraction because these warriors, these enemies, only have the members that are associated with iWarrior, which is attack and also name, health, take damage, which means that in this function we don't have access to do anything else, like potentially look at, for example, um, let's say like we go into this minion class, we don't have access to this threat level. Why? Because threat level is actually only accessible to the minion class or the goblin class or the enemy interface. So we'd actually have to change this to enemy, which we actually could because each one of these gremlin minions and goblins can also implement the warrior interface. The reason why I did this is because I wanted to show you guys how we can create a main character that's of a main character class and then an enemy army of a bunch of goblins, gremlins, and minions, but still have the unified access of an interface. Because to me, that's the whole point. And I guess that's what they mean when they say polymorphism. So that's pretty much the video for today. I hope you guys learned something. I promise to actually leave the code in the description this time. I'll go back on my previous videos and make sure I fix those mistakes. And if you guys have any questions, please let me know. And I hope you guys have a great day. Goodbye.